In this lesson, we're going to go over solving radical equations. Specifically, we'll apply our knowledge of radicals and solving equations that we've done previously in this class to solving radical equations. We'll solve them and then we'll learn to check our answers. So solving radical equations, we have to make sure that the radical is by itself when possible and that there's only one radical per side of the equation. And I'll show you why when we begin our examples. We want to get rid of the radicals, solve, and then for these problems, we have to check our answer. Example 1, solve for x. So we have the square root of 9 minus 3x minus 2 equals 4. So to start this problem off, we want to isolate the radical. So we'll add 2 to both sides to get the square root of 9 minus 3x equal to 6. Now we have to get rid of the radical. So this is the square root of 9 minus 3x. We can square both sides to get rid of the radical, and I'll show you why. So let's say we have square root of 25 and we decide to square it. This means square root of 25 times square root of 25, which would give us, I think, 625. Let me double check that. And the square root of 625 is 25. So when you square a radical, you're left with whatever is on the inside. And the same is going to happen here. So when we square the square root of 9 minus 3x, we're left with 9 minus 3x, and then 6 times 6 is 36. At this point, this becomes a linear equation that we've solved previously. So we can solve for x by subtracting 9 from both sides, and then we would divide by -3 to get x equals -9. And now we have to check our answer. Anytime we check our answer, we plug in our x into the original equation. So we're going to plug it in at the very beginning. The square root of 9 minus 3 times the value we got for x minus 2, and we want to know, is that equal to 4? So now you'll simplify the right side and the left side to make sure that the left side equals the right side to know that your solution is true. So this becomes 9 plus 27 minus 2 equals 4. Square root of 36 minus 2. And we come down to 4 equals 4, which tells us that our solution is in fact true. So our final answer is x equals -9. No, your answer is not 4. You just happen to get 4 equals 4 to prove that your solution is a solution and that it solves the equation, but your final answer is the value that you got for x. Example 2, solve for x. So we have 9 plus the square root of x plus 7 equals 2. So we start by isolating the radical or getting it on a side by itself. And here we have x plus 7 equals -7. Now at this step, you may notice that there would be no solution. You can't take the square root of a number and get a negative. The square root of 49 is just 7. Okay, but let's say you solve this one. So we'll square both sides to get x plus 7 equals 49. And then we subtract 7 from both sides to get x equals 42. All right, great. So let's check your answer. We would have 9 plus the square root of 42 plus 7, and we want to know, does that equal 2? So we work on the left-hand side and the right-hand side. We would have 9 plus the square root of 49 equal to 2. 9 plus 7 equal to 2. And does 16 equal 2? Nope. So in this case, there's no solution. Example number 3. Square root of 5x plus 16 minus square root of x plus 4. Now the temptation with this one is to start off with squaring both sides. But if you do that, take a look with what happens. If you were to square the entire left-hand side, this means square root of 5x plus 16 minus square root of x plus 4 times itself. Ran off the page. But if you were to FOIL or to distribute and multiply that out, you would not get that the radicals cancel out. And so that's why in one of the steps that we say to get the radical by itself on a side, or at least have only one radical per side. So we'll start off by adding the square root of x plus 4 to both sides to get the square root of 5x plus 16 equal to the square root of x plus 4. And now we can square both sides to get 5x plus 16 equal to x plus 4. So we get our x's to one side and our numbers to the other. And here we get 4x is equal to negative 12, divide by 4 to get x is equal to negative 3. Okay, and now we check our answer. 5 times negative 3 plus 16 equal to x, minus the square root of x plus 4 equals 0. Okay. So now we simplify the right-hand side and the left-hand side to make sure that the equation is true. So this is negative 15 plus 16 minus square root of 1 equals 0. Square root of 1 minus square root of 1, and so we get 0 equals 0. So in fact, x equals negative 3 is a solution. Example 4, solve for x. We have one radical per side, or it's isolated by itself, so we can start off with squaring both sides. Okay. So this is 40 minus 3x equal to x minus 4 squared means x minus 4 times x minus 4. So on the right-hand side, you would use FOIL. Okay, but I'm going to jump right in. So we have x squared. So this is going to become a quadratic equation that we've learned how to solve. We solve quadratic equations by factoring, by the square root property, or by the quadratic formula. But in order to do that, our quadratic equation needs to be set equal to 0. And you know my strategy, keep x squared positive. So I'm going to move over the 40 and the 3x. So we get 0 is equal to x squared minus 5x minus 24. Okay, and then whatever method you use, I'm going to solve this by factoring. So that would leave me with x minus 8, x plus 3 equal to 0 to get x is 8 and negative 3. Okay. So with this problem, I don't have enough room to check both answers, but let me show you what happens with negative 3. So we would plug it in to the original. Okay, and then simplify. So this would be the square root of 49 equal to negative 7. The square root of 49 is just 7. Okay. So with that, this is not true. So you would have to throw out x equals negative 3 as a solution, and if you check 8, x equals 8 does work. So in this case, we ended up with 2 answers, but we had to throw one away because when we plugged it into check, it didn't make the equation true. Example number 5. So our radical is isolated by itself. We can square both sides. And so we get x squared equals 9x minus 20. X squared is a quadratic equation, so we'll set the entire thing equal to 0 and then solve it using one of the ways that we've talked about before. So we'll subtract 9x and add 20 to get x squared minus 9x plus 20 equals 0. I'm going to solve this one by factoring. So two numbers that multiply to 20 add to negative 9. X minus 5, x minus 4 equals 0. X would be 5 and 4. Okay, and in this case, both of those numbers are going to work. And I'll leave it to you to check it. Thank you for watching. If you have any additional questions, please feel free to reach out to me.